Let's talk about one of the coolest things that the universe just does, something called gravitational lensing. And chances are you've already seen gravitational lensing, even if you didn't realize it, because it is all over the place in a lot of the images that come from the James Webb Space Telescope. But what is it? Well, it's a phenomenon that arises thanks to general relativity, which explains that gravity works by massive objects like stars and galaxies warping the fabric of space. And weird things happen when you warp space. I mean, for one, gravity. Like, Earth stays in orbit around the sun because it's sitting in that little indent in space-time that the sun created. But objects with mass, like the Earth, aren't the only things impacted by curved space-time. Light is also affected. Let's imagine you have a giant object like a galaxy cluster, hundreds if not thousands of galaxies gravitationally bound together. That is going to warp space a lot. As light from behind the galaxy cluster passes by it on its way to us, it won't just continue in a straight line. As it goes into the curved space-time, it will follow the curve. That galaxy cluster acts like a lens. It focuses the light from background objects, and that has some really strange effects. If there is perfect alignment between us, the observer, whatever object is acting as a lens, and the background object, you can get what's called an Einstein ring, where the light from that background object gets smeared out in a beautiful circle around the lens. A lot of times things aren't that perfect. There's some offset, so you get more of arcs or distortions in the image. You can wind up seeing the same object multiple times in one image. And because the light from that object took different paths of different lengths to create each of those multiple images, that means we can actually see the object at different times in its history. Which is super cool when you're looking at something that varies a lot over time, like a supernova. We can see it at different points of its evolution, all in the same image. Gravitational lensing can also magnify the background objects, which makes it really useful when we want to study really distant and faint objects. We can see them a lot more clearly if they're being lensed. And this process also teaches us about the lens itself, because we can use the way it distorts light to calculate things like its mass and its mass distribution, its dark matter content. And the best part of all of this is just a thing the universe does. We don't have to build any experiments or do anything fancy, we just have to look up and there it is. So next time you see a JWST image with weirdly distorted galaxies or rings or arcs, chances are you're seeing gravitational lensing.